Hello, we are here with a presentation on the topic of electron spin. Our team includes Sandeep, Gayathri, Anju, Badsha and myself. When a question is asked, what is electron spin? Generally, people have an assumption that it is the spinning of electron in its own axis. But when we go deeper into the subject of electron spin, we come to know that it is not merely the spinning of electron and its axis, rather a lot more than that. So in this presentation, we will be dealing with a lot more characteristics of electron spin, which includes its origin, concept, theorems, experiments, etc.
Electron spin is a property you can measure. It can take different values and can change over time. First of all, spin is not spin. For if you were, then the electron have to spin million times the speed of light. Then it would be disintegrated into different pieces, so it would suggest that electron is not a point particle. Another thing, moving charges produce magnetic field. So charge moving in circle would produce magnetic moment and its charge behaving a kind like that of magnet. So what the physicists did, they placed two specifically designed magnets like this. They took atoms of silver, which can roughly be assumed to be small bar magnet. As it has only one unpaired electron in the outer shell, when these atoms passing through the magnets, it's like throwing in magnetic moments. So the beam goes in between these magnets and what you get on the screen. So here's what expected. Here comes an atom and it has magnetic moments in random directions. Therefore you're going to get as much like this. Some are going to be deflected a lot because they have a lot of C component of magnetic moment, and others are going to be deflected only a little. So this is where an interesting thing happened. They got one peak here, an empty space, and then another peak here. This was termed as space quantization. This space was about 1/5 of the millimeter. It was not that big, but it was a clear thing. So everyone was confused. So the idea of spin was proposed. It is now understood that these electrons have two states of spin, spin up and spin down, corresponding to the position of beam on the screen. Every other state of spin is made up of up and down spin states. So spin is an intrinsic property of the particle, just like mass or charge, and what we can measure is their magnetic moments. Spin statistics theorem. Basically, this theorem tells us that based on the spin, particles can be divided into two groups, fermions, bosons. Fermions. They have a spin of plus or minus half. They are basically the particles that make up matter. They are called fermions because they follow the Fermi-Dirac statistic that these type of particles obey the Pauli exclusion principle. It means that two fermions can be in the same state. If two electrons are on the same orbit, they must have opposite spin. The wave function of fermion look like this. It's antisymmetric. Bosons. They are the ones with integer spin like photons, gluons. Photons have a spin 1. Higgs bosons are 0. They are called bosons because they obey Bose-Einstein statistics, which means they are not subjected to Pauli's exclusion principle. This is superfluidity, a state with no viscosity or friction present, result of Bose-Einstein condensation, which occurs at very low temperature. The wave function of ozone looks like this. It is symmetric. Just like the compass needle, the spin has the tendency to align along the magnetic field. If we take the electron and place it in the magnetic field, it will have two basic quantum states, spin up and spin down, also called 0 and 1 states. If we prepare the spins in the 0 state, we can turn it towards the 1 state by irradiating it with an electromagnetic field that oscillates with the frequency given by the equation F is equal to energy of state 1 minus energy of state 0 divided by Planck's constant. This method of controlling magnetic spin is called magnetic resonance. They find many applications in devices such as MRI devices in hospitals.